Hey guys, today we are solving equations again. The great thing about today though is we don't have to worry about plus or minus, we don't have to worry about any of that. The only thing we're doing now is we're canceling out some roots. Now this is a problem just like what we've done before, right? To cancel out this cube root here, to solve for it, we're first going to isolate it, but it's already isolated, and then we're just going to raise both sides to the power of the index. Raise both sides to the power of the index. So it's going to cancel this out, and we're just going to get 2x plus 7 equals 3 to the power of 3 is, of course, 27, right? So, and remember, you can use your calculator to do that. 3 to the power of 3 is 27. Now, then we just solve it. We don't have to worry about plus or minus or anything like that. Now we're just going to go. In fact, for all of these problems, you're going to get just one answer. So let that help you out a little bit. We're going to minus 7 here, minus 7 here. We're going to get 2x equals 20. Divide both sides by 2. And we're going to get our answer of x equals 10. Now the thing is with these problems, we need to take a moment to check them, okay? So we're on all of these problems, we're going to take a moment to check them. Now to check them, remember, you use math 4 to make a cube root, and you can use math 5 to put whatever you want as your index. So why don't we get some practice in? We're going to check this. We're going to go to the cube root of 2 times x. Now instead of having x, we're going to plug in 10 to make sure it works. 2 times 10 plus 7, and we're going to ask the question, does this equal 3? And so we're just going to plug this in. So I'm going to pull up my calculator. The cubed root of 2 times 10 plus 7. So here we go. We're going to go math 4 to get cube root. So we're going to do 2 times 10 plus 7 in here. Hit enter, and hey, look at that. It equals 3. So we got the right answer. So x equals 10 is correct. So let's take a look at number 2. This is the same exact thing. The only difference is that my index is 4 instead of 3. But once again, we do not have to worry about doing a plus or minus on any of these, okay? So it doesn't matter if it's even or odd. It's not like what we did on Friday. So in this case, what we're going to do is we're going to start off by minusing 24 to both sides. That's going to give me 8 times the 4th root of x equals negative 24, because we're trying to get this section right here by itself. So everything on the outside of that section has to be gotten rid of. On our first problem, everything was inside that root, so I didn't have to get rid of anything. In this case, everything's on the outside of that root, so I have to get rid of it. So we moved to the negative. I don't know why I wrote 25 there. This should be a 24, of course. I'm sure some of you were screaming at your computer screens. Okay, then we're going to divide both sides by 8. And we're going to get the 4th root of x equals negative 24 divided by 8 is going to be negative 3. All right, now to get rid of this 4, to get rid of this 4th root, we're going to have to raise both sides to the power of that index right there. So just raise both sides to the power of 4. Remember, if you start with a root, you're going to raise the power to cancel it out. Okay, so let's do negative 3 to the power of 4. So I'm going to pull this up. Negative 3 to the power of 4 is 81. Notice how I put the parentheses right there to protect that negative. Okay, so we get 81. So we're going to say x equals 81. However, we're going to have to be extra careful checking this one because we had a negative that we raised to the power, and those don't always work out the correct way. So let's plug this 81 back into my original equation to see if it actually works. So we're going to go 8 times the 4th root of, and instead of having an x, we're going to write 81 plus 24, and we're going to ask, does that equal 0? Let's see. So we're going to go 8 times math 5. Oops, I put that 8 up there. I hate it when it does that. Okay, so it's going to be 8 times the fourth root of 81, go to the outside, hit plus, what was it? It was plus 24, not 4, so we'll go back, plus 24, hit enter. Holy cow, that equals 48, not 0. So that 81, not a true answer. So that is an extraneous solution, and my real answer is that there is no solution for this one. No solution. All right, now number 3. Number 3, we have an x on my other side, but do not let that freak you out, okay? That x on the other side, remember, it's just going to make it quadratic. So let's plug that. Let's get rid of this square root, and we can get rid of that square root by, remember, there's an invisible 2 right there. So we can raise both sides to the power of 2. It'll cancel that out, and we'll get x plus 10 equals 3x squared. Now 3x squared is going to be equal to 9x squared, like that. Okay? Then we need to solve this quadratic equation. We're going to do this by doing our x and our plus, just like we did on Friday. So we're going to have to bring my x over here, bring my 10 over here, and we're going to get 0 equals 9x squared minus x minus 10. Then I can do my x and my plus. On top of my x, let's label my a, my b, and my c. So we're going to go a times c. So on top of this, we're going to have negative 90. On bottom, we're going to have my b, which is negative 1. Two numbers that multiply to equal negative 90 but adds negative 1 are going to be negative 10 and 9. So in my plus, we're going to have negative 10 and 9. And so we're going to have 9x minus 10 and 9x plus 9. So my first factor, we have 0 equals, my first factor is 9x minus 10. My second factor is 9x plus 9. We can reduce this, though. We can reduce this to become x plus 1. Divide both of these by 9, right? So there's my second factor, x plus 1. Okay, we can set both of these equal to 0. We can go 9x minus 10 equals 0, and we can go x plus 1 equals 0. Minus 1 to both sides here, you get x equals negative 1. Add 10. Both sides here, you get 9x equals 10. Divide both sides by 9. And fraction answers still count. So we have x equals 10 over 9. And we have x equals negative 1. Now, I told you earlier that we can only have one true answer, right, for these problems. So we're going to have to check both of these and see which one is the real deal. So I'm going to take this negative 1, plug this one in first. We're going to go negative 1 plus 10. And does that equal 3 times negative 1? Good question. Well, negative 1 plus 10 is 9. 3 times negative 1 is negative 3. The square root of 9 is 3. And unfortunately, 3 does not equal negative 3. So that is not a correct answer. So now let's check 10 over 9. So let's go 10 over 9 plus 10 and ask, does that equal 3 times 10 over 9? Well, I might need some help with this one. So I'm going to grab my calculator. And I'm going to plug both of these in. So we're going to go the square root, because this one's just square root of 10 over 9 plus, what was it? Plus 10. See what that is. All right, that's 3.33 repeating for forever. Okay? So now let's try what happens when I have, what happens when I have 3 times 10 over 9. So let's go 3 times 10 divided by 9. See what that gives me. Hey, that gives me 3.33 repeating again. So these two actually equal each other. So x equals 10 over 9 is the correct answer. Even though it's a fraction, even though it's weird, it was the correct answer in this situation. Okay, let's turn the page. And let's try these next few. So let's start with number 4. Number 4, we have 1 on each side. So what we're going to do is we're going to isolate both of them. And the way I'm going to do that is I'm going to add one of these over to this other side. So we're going to have the 5th root of 4x plus 1 equals the 5th root of x plus 10. Then I can cancel out both of these 5th roots at the same exact time by raising both sides to the power of the index, to the power of 5. So we can raise this side to the power of 5 and raise this side to the power of 5, and it cancels. Look at this. It's just going to be 4x plus 1 equals x plus 10. And now we just solve it. We can bring this x over to this side. We can minus 1 over to this side. And I can get 3x equals 9. Divide both sides by 3. And these cancel. And then 9 divided by 3 is 3. So x equals 3. Okay, we're going to check this real quick. All right. So to check this, we need to plug it back in, right? So we're going to say, okay, if these two do indeed equal each other, and plug it back in. So we're going to go the 5th root of 4 times 3 plus 1, and we're asking, does that equal the 5th root of 3 plus 10? Well, 4 times 3 is 12. 12 plus 1 is 13. So this side is going to be the 5th root of 13. And this side, 3 plus 10 is 13. So this one's also going to be the 5th root of 13. And we don't even have to plug this one into our calculator. We can just see that these two equal. The 5th root of 13 plus the 5th root of 13 is congruent. So that checks out. That's a true answer. Okay. Number 5 here. Number 5. Once again, we are solving for the piece of the puzzle that is underneath the root. And this -3 and this -4, they're on the outside. So we need to get rid of those two first before we can raise to the power of the index. So we're going to add 3 to both sides to start. That's going to give me -4 times the 6th root of x equals -11 plus 3 is -8. Then we're just going to divide both sides by -4. And we're going to get the 6th root of x equals -8 divided by -4 is 2. Okay, this is the first time we've seen a 6th root. But we do it just the same as anything else. To get rid of that 6th root, we're going to raise to that power. So we're going to raise to the power of 6. So I'm going to raise this side to the power of 6, and I'm going to raise this side to the power of 6. And we're going to get x equals 2 to the power of 6. Now, I got to use my calculator for that. So I'm going to pull this up, and we're going to go 2 to the power of 6, and that equals 64. Okay, so there is our answer. But remember, we still want to check this. So I'm going to go over here. We're going to go -4 times the 6th root of 64 minus 3 equals -11. You can plug this into our calculator. We're asking, does that equal -11? So in my calculator here, we're going to go -4 times, I'm going to go math 5. We're going to put a 6th root of 64 there. Oops. 64. Close those parentheses. And then we are going to -3. Okay, let's see what that gives us. Hey, it gives us -11. So it checks out. That is the correct answer. All right, our last problem today, number 6 down here. We're going to have x minus 1 equals the square root of x plus 1. That square root's by itself. To get rid of it, we're just going to raise both sides to the power of 2, because there's an invisible 2 right there. These will cancel, and I will just get x plus 1 equals x minus 1 squared. Okay, bear with me. We're squaring this entire side. It's been a while since we've done this. So let's take this over to the side and let's work this out. Let's go x minus 1 squared equals x minus 1 times x minus 1. So we're going to go x times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. And negative 1 times negative 1 is plus 1. Combine like terms now, we're going to get x squared minus 2x plus 1. So this is what's going to be on this left side. We're going to have x squared minus 2x plus 1 equals x plus 1. And now we're just going to solve this by factoring. So look what we're going to do. We're going to need to bring this, we're going to minus x to both sides, and we're going to minus 1 to both sides. So these cancel, and I'm just left with 0 on this side. 1 minus 1 is 0. So we're going to have x squared, negative 2x minus x is negative 3x. We're going to factor this out by pulling out the GCF. So I'm going to pull out the GCF here, and my GCF is going to be x. So we're going to go x times x minus 3 equals 0. So these are my two factors, x and x minus 3. We can set them both equal to 0. We go x equals 0 and x minus 3 equals 0. So this is one of my answers, x equals 0. My other answer, if I add 3 to both sides, I'm going to skip down here, it's going to be x equals 3. So there's my other answer. But remember, only one of those can be our true answer. So we're going to plug them both in to check. Start with 0. 0 minus 1 equals the square root of 0 plus 1. Well, 0 minus 1 is negative 1. And this is the square root of 1, which is 1. Oh no, it doesn't equal. So 0 is not a true answer. Let's try 3. If I plug in 3, we can go 3 minus 1 equals the square root of 3 plus 1. 3 plus 1 is 4. The square root of 4 is 2. And then 3 minus 1 is also 2. So this one is my true answer. X equals 3. We're going to skip that summary, and that's going to be the end, guys. Thank you for paying attention. I hope you have a great rest of your day.